How's it going, everybody? Welcome to another edition of Math with Mr. Stevens. Today we're going to be in Module 4 on page 156. This is going to be a fairly short one today. We're just going to be looking at this one pair of graphs here. Just like the last video, we're taking a look at this in terms of comparing equations, not just in terms of what they look like as equations, not just what they look like in terms of a table, but here looking at what they look like on a coordinate plane. And then making a couple of determinations, some things like which graph is steeper, how do you get from one point to the next, and what does that essentially mean? Asking about slope. And so we're going to take a look at and find the slope of these two lines, and then we're going to compare them, see which one is obviously steeper than the other. These two, the evidence is pretty clear. And then we'll talk about what that means in terms of its equation. Okay? So we got our two. We've got graph A and we've got graph B. Pretty straightforward. It should be very clear of which one is steeper. This line you can barely see. It is nearly horizontal. All right. This line is going way from here to here. Here's our points to make them a little darker. Okay. From here to here, that's a very, very, very slight incline going all the way across. Where here the incline is far more pronounced, and it's much easier to see how it's going, in this case, up at a very nice angle. Okay, so graph A very clearly has the steeper slope between the two. Now they want to know what are the directions to get from one point to the next. And so we're going to look at these two graphs, we're going to look at these two lines and determine how do we go from this point here to this point here, and how do we go from this point here to this point here, which each one of them, and we're going to compare essentially the journey that is required. So here, as we said in the last video, we're looking at rise over run, and that is the change in y divided by the change in x, or as a fraction, put together as a ratio, as the change in y over the change in x. So the change in y, that is the change in our vertical distance, so either going up or going down. In this particular case, we are going up. Okay, so we go up 1, 2, 3, 4. So we're going up 4. All right. That's our rise. Then our run is our horizontal change, either going left or right to find the next point on our line. And so if we go right, we're going to go 1, 2, 3, 4, 5. So 4 up, 5 to the right. Okay, so for graph A, to describe our change from one point to the next is 4 up, 5 right. Okay? Both of these are positives. Looking at graph B, very similar. Okay, so we have this point here is at -4, -5. And so to get to this point here, which is at 8, -4, okay, we have to look at the rise. So how do we get from -4 or -5 to -4? Well, then that's an increase of 1. And we have to look at the run. How do we get from -4 to +8? This is a distance. So there's a +1 there. So the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a +12 run. Okay. There is another way you can do this. You don't necessarily have to just find 2 points and then draw how to get from one point to the other with arrows like this, and then count. What you can do is you can essentially just take a look at the two ordered pairs that make your 2 points on this line. We have -4, -5, and then 8, -4. Well, how do you get from -4 to +8? If you think about that on a number line, you'd have to move 12 to the right, which is what we did here. How do you get from -4 to -5 for your y value? You would have to go up 1, which is what we did. Okay, so that same type of thing is required. So you can either count, like we've done, or you can just look at them in terms of their difference between your coordinates as an ordered pair. So let's look and put our answer for graph B. So for graph B, our distance or our directions are 1 up, 12 right. Okay? And so we need to remember this as we are looking at these as directions. When we are moving up and to the right, both of those moves are positive. If, in the future, we go down or we go to the left, then those are negative movements. And so those are going to be negative when we put them together within our ratio, which we're going to do here. We're going to put them together as a ratio, then we would have what's called a negative slope. It's fine. It's perfectly fine to have a negative slope, but that's what you get when one of them is negative. Okay? If they are both negative, if you're moving down and to the left, then you would have technically a positive slope. To go from, and if you think about that, that should make sense. If you go from one point or from this point to this point, you're moving left and down. Going from this point to this point, you're moving left and down. Both of those things are both negative movements, but as we see here, they're also positive movements going from one to the other. So you're going to end up with a positive slope either way, whether you have two negatives or two positives as your movements. When you have one or the other, then you're going to have a negative slope. So let's find what the slope of graph A is, and let's find what the slope of graph B is. Okay? The way we do that is we look at the change in y over the change in x. Okay? So our y for graph A, okay, our y is an increase of 4, so it's a positive 4. And our x, our change in x, is an increase of 5. So our slope, we would say our slope for graph A would be 4/5. That's it. That's how you find your slope. You look at your change in y and you look at your change in x. Same thing is going to be true for graph B. Let me find some space here so we can see it. You see that? Yeah, we can see that. Cool. Okay. Same thing is going to be true for graph B. We are looking at the change in y, which is a positive 1, divided by the change in x, which is a positive 12. And so our slope for graph B is 1/12. Neither one of these fractions can be reduced, and ideally, if we can reduce them, we would reduce them, but since neither one of them can be, we're just going to leave them as is. When we go to make the equation for these two lines, and we're not going to do that yet, okay, that'll be something we do a little bit further on down the line. Right now we're just looking at slope. That's one part of an equation. So when we're looking at the slope, this is how we find it. We take the change from one point to the next, and we look at it in terms of its change in elevation, so up and down, and in change of its directional value between right and left. Okay, so we're looking at up and down change divided by left and right change. Okay, change in y versus the change divided by the change in x. This is what's going to give us our slope. It's the same way we get our constant proportionality. Okay, so hopefully this helps. This is the only one we're doing, graph A, or pair 1 with graph A and graph B on page 156. Hope that was helpful. See you later. Adios.